Thank you. I've got 40 minutes. I've got this talk at the recent Spark Summit. It took me 1 hour and a half, and I barely fit all the content I wanted to share with you or with them. So 40 minutes might be a little bit tricky. So let's get started. So internals of Apache Spark SQL. Well, I can talk about this because I've spent the last 5 years with Spark only. I'm independent consultant. I'm doing Spark only, plus Kafka because it's pretty common to use Kafka and Spark. So if you've got any questions about Spark SQL, about the internals of Apache Spark or Spark SQL in particular, let me know, okay? I'll be around till my flight at 7 p.m. today. I apologize for leaving early. I know the conference is it's a huge success. You know, the weather is so cool. You know, so overall, it's a very nice vibe here. So as I said, I'm Jacek Laskowski. Thank you for being with me here for 40 minutes with Apache Spark. I'm independent consultant, so the market always challenging me with my knowledge and skills about Apache Spark, Kafka streams, and the one and only programming language is Scala. I left Java at the time when I was awarded this title, Java Champion, but I'm still with JVM, so I'm promoting using JVM where I can. I'm responsible for development, consulting, training, all things Spark SQL and Kafka. You can contact me at jacek@yapila.pl or follow me on Twitter. And I strongly recommend following me on Twitter because you can learn Spark and Kafka streams and Scala through, you know, this 145 characters. It's more than this. I'm just including four screenshots. So whenever I've got something to share, I describe it in more details. I'm just taking 4 screenshots of what I would share with the audience and then provide a link. And you know what? No, I can see people are not very willing to, you know, visit my links. They are only willing to read all the screenshots. So now I see that people are more visual than you know, interested in reading, even though they are reading when I'm taking screenshots. I don't know how it works, but it works like this. Okay, so I'm best known by my Gitbooks. I'm writing at the same time simultaneously 5 Gitbooks about what I see in the code, in the source code of Spark and Kafka. And the reason I'm with these 2 products and I'm describing what I see, because I wanted to, or I still want to get better at Spark and Kafka, and moreover at Scala. So the only reason I started, you know, describing, you know, these tools is just to get better at Scala. Yeah, I'm pretty, you know, often at, or yeah, I'm pretty active at Stack Overflow, so you can find me over there too. Okay, so this is the agenda. So you can see almost 10 points to discuss. So you've got half an hour, 10 points, so we've got 3 minutes each. Oh, that's gonna be tough. Anyway, so structured query, just very briefly, but before I describe this, let me ask you this. Who is using, or who's been using Spark? And yeah, just raise your hand. Okay. Okay, so half the room has been using or is about to use Apache Spark, which is okay. And who's been using Spark before Spark 2.x? Okay, so half the people who rose their hands about, you know, using Spark rose their hands for Spark 1.x. And you know what? That's the problem with these people. Well, not really with you, but many people are struggling with this change of direction from using RDDs into more higher level API, which is called Spark SQL. And that's what I see that I need to, how to say, tackle with whenever I'm explaining Spark SQL. So structured queries are, for those who've been using Spark in the past, you know, before Spark 2.x, it's all about structured queries. And structured because we need to know a little bit about our data. We are with Spark because we need to crunch, process our data, and to, have a room, a space for lots of data. We need to tell something about, what this data looks like. Okay, and if you know types, you can prepare space for this data. You can say, okay, if it's a string, okay, we can do much. We cannot do much about it. We just need to, reserve 1K. For example, 1K, but if it's int, we know that int is limited to hold this range of data, and we can just preoccupy data we need, okay? And whether it's null or not, so nullability also tells us, how to accommodate this, whether the data exists or not. So all this information that come out of our structured data tells us how much space we need, how to manage our space, our memory, available memory. And since we are speaking about large data sets, we need to know a little bit about our data before we execute our queries, so we can execute them. And the nice thing about Spark SQL is that whatever you are using for expressing your queries, you will always end up with something that's called structured query, which is by type, which is data set or data frame. Okay? So whether you are using, dataset API for Scala, Java, Python, or perhaps R, I'm not sure about R because I've never used R with Spark, but you can also use SQL. So you will always end up with dataset. And the difference between dataset and data frame is that, type fans wanted to have something that Spark, Scala compiler, or Java compiler can check at compile time. And it's very important to make sure that your program compiles, which is to say that your program may run in production. It's different from what you can expect from Python or from R programs. Until you execute, my experience says that until you execute your R or Python or SQL programs, you won't know whether they are fine or not. Is this correct? Is there anyone who would disagree? No, okay, so you prove my point. Thank you. So whether you're using this or that, it doesn't really matter, okay? But for Spark, Java or Scala programmers, it's very important because we care about types. So why is structure important? Because we need to think about storage. That's the main point, okay? The less space we use for larger data sets, the better, okay? So query languages in Spark SQL. We've got 5 different query languages. Well, we've got 2 main languages or 2 APIs. So let's say we've got 5. Let's start with 5, okay? Because I want to impress you with what Spark SQL supports and can do for you. So we've got SQL because this is the query language people, familiar with queries would use. So SQL, then you could express this SQL using Scala, Java, Python, or R. Yeah, I know that you could argue that these are not query languages, but if you look at the API that resembles what you can do with SQL and that provide more type safety, you would, I'm sure you would accept that these are also semi-query languages, okay? But they are definitely supported by Spark SQL. Okay, and we've got these 2 different data structures called data frame and dataset. The difference is in, more visible for type-oriented people. Data frame is just type alias for something that's, for something that's dataset of rows. Okay, very good. So SQL, good old SQL, it's all supported. It came from this support from Presto, Facebook database. So they describe SQL by Antler grammar. It's part of Spark SQL. They borrowed it, and they built the SQL support based on this grammar. Then they added some support for, well, not some support. They've got it pretty decent support for HiveQL, Postgres SQL, Microsoft SQL, and Oracle SQL. And the reason they did it was that just to make your transition from this relational, pretty costly, cost-ineffective solutions into Spark, which is supposed to be much more elegant, effective, and cost-effective. Okay? Very good. So we've got data sets and data frames, and we've got schema. So data frame is described by this schema, and at the very low level, we've got something that's called encoder. Encoder is SERDES, serialization and deserialization framework, something you may have noticed or you may have worked with in Kafka, where there is this explicit conversion between bytes and your JVM object. So think of it. Spark is written in Scala. Scala runs on top of JVM. The thing we don't like much, sometimes, we don't like much about JVM is garbage collector. Well, we love it. That was the reason for the success of Java and JVM platform in general. But overall, we want to avoid GCs at all costs. The less GCs, the better. So we want to avoid loading data sets, large data sets onto JVM. Why? Because the more data on JVM, the more frequent GCs, correct? Which would impact the performance. So what to do to avoid this? Well, you don't have to do much, okay? Well, nothing at all, to be honest. You need to use Spark SQL that knows that unless you do some tricks that would load your data, which I highly discourage, which I'm not recommending people doing, you won't suffer from much GCs because of the way Spark SQL loads data. It uses this, something that's called row encoder, and this row encoder will give you a sense of having data, but not on JVM, okay? Which is pretty cool. Okay, so, and data sets, it's a more type-safe way of doing this loading. So you've got encoder, serialization, and deserialization API. And, well, it's all about managing memory outside JVM. So yes, if you've ever thought about how Spark does memory management, and you thought about some relationship with, JVM or GC, or, whether Spark is another garbage collector, yes, that's correct. Spark manages data on its own. It leaves JVM and manages data using sun, misc, unsafe. Yes, it is unsafe, but it's unsafe, but it's safe for Spark users. You don't have to worry about it. Okay? But since it's a talk about internals of Spark SQL, you have to know it. If you know that it uses sun, misc, unsafe, now your problems with cluster managers or issues like Yarn, like Mesos or others would make sense. They would tell you, hey, there is this memory consumption above your memory limits. And you say, how could it be? Since I, describe my memory requirements to be 4 gigs. Well, because of this serialization and deserialization API, it uses something outside. So for Yarn, you have to specify extra parameter to say, this is the extra memory, which may be higher. The requirements for this external memory might be higher than what I really need for my data. Yes. Okay, so Project Catalyst. Project Catalyst is the gist of Spark SQL. It's once you understand Project Catalyst, there are 2 projects. You will be fine with Spark. There are 2 projects with, I've got so much to say and so little time that I sometimes will, my 2 threads that wanna, share so much with you will interleave. So I apologize for this. So you've got Catalyst and you've got Tungsten. These are the 2 products or 2 projects, 2 modules that were part of Spark 2.x that made so much success, or that turned Spark into an even more successful project. So Project Catalyst, one of the two main players in Spark 2.x, creates something that's called tree manipulation framework. This tree manipulation framework is made the foundation for Spark SQL. If you think about SQL and about query plans, and there is this notion of query plans in Spark SQL, you will see trees. Well, just like in Matrix. You know, these people saw, people walking around in these numbers, right? So, and I'm pretty sure that you also watch Inception and other, crazy movies. Some people cannot understand them, but we could. And we appreciate them. So, speaking about Matrix and Inception and other movies, let's go back to Catalyst and see trees in all the things Spark SQL. Whenever you build your query, you build structured query, you build tree, okay? And this tree starts with first operation that loads data. There might be more than one loading stage, or not to confuse you with stages in RDDs, but step that loads data. Then there is this join or union that combines all this data. So when you see at all the operations you are doing, you are creating trees. And these trees are the foundation of Spark SQL and foundation of Catalyst. So you've got tree manipulation framework, and you've got the basic data structure called tree node. Tree node, that is a recursive data structure that can have 0 or more tree nodes. So you have tree node that can have another tree node, another tree node, and another tree node. So you build a tree. So you've got also rules. Rules to manipulate this tree. Well, if you've ever studied computer science, you remember that this recursive data structure have this nice property of being pretty simple once you grasp the concepts of being simple. Well, they are not simple at first because somehow it's hard to explain something by saying that it's 0 or more nodes. So where's the start? So is 0 part of numbers? Romans didn't use 0 and they collapsed eventually. We use 0, but for many people, it's still unclear whether 0 is positive or negative, or whether it should be even asked about it. So 0 is 0, and there are positive and negative numbers. So going back to our rules are to process recursive data structure called trees. So if you write your query, and you apply a rule to process one node, you can recursively apply this rule to all the nodes that are available in your query, and you will process your entire query tree. And that's the gist of Catalyst and Spark SQL. Okay, so tree node. Tree node is a node with children. So you've got node with nodes, and this is the view at the source code of tree node. And you know what? I cannot explain it in enough details from Scala perspective, Scala programmer perspective. I'm not at this level, and look at this very basic, fundamental data structure in Catalyst, in Spark SQL, and how many features, Scala features, it uses. So there is this abstract class, which is pretty obvious even for Java programmers. I say even because I'm the Scala programmer, and I believe that Scala is more complex, more advanced than Java. So abstract class, easy. But then you see something like tree node, base node, and this smile. What is this? Is it a kind of a tweet, or is it a message to my friend? Well, it's a way to express that you accept tree nodes. Come on, how is it possible that you create tree nodes out of 3 nodes? So where do you start? And that's the toughest part to explain for me too. So, and then there's extends product, and then you've got this self-base type. What is this self-base type? How is this different from this? And how can we know that we've got access to self and this and other questions? overall, it's pretty nice data structure. I'm yet to study it in enough details to understand all the benefits it brings to Spark SQL. Okay, so we've got 3 nodes. Now, we know it's an abstract class. For those who are not familiar with abstract classes, abstract class cannot be instantiated, meaning you cannot create objects out of this template, out of this abstract template, because abstract classes and classes in general are templates for something we can instantiate, right? Right. So we've got 3 nodes, and this is the inheritance tree. So we've got query plan, and we've got expressions. These are the sub-tree nodes, so to speak. And under query plan, we've got Spark plan and logical plan. So out of these 4 basic data structures, Spark SQL brought all the goodies to you, and now you don't have to worry about all this optimization, how to process big data, because of this. Okay, so query plans, we've got query plan, which are Spark plan and logical plan. And if you've ever worked with databases, relational databases, you've heard about query plans. Query plan describe your query from database, from processing engine perspective. Processing engine needs to know what you were to express. So be it SQL, Scala, Java, Python, or R, it doesn't really matter. But this processing engine needs to talk to you in its own lower level language. So it translates all the operators into these Spark plans and logical plans. As a matter of fact, it translates your queries into logical plan, tree of logical plans. And this is an example of, very simple join. It ended up as a broadcast hash join because of the size of the data. So one side of your join became broadcast to nodes, and it's the best join you can ever have, okay, with this data. And so this is just a tree, okay? A tree of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes. Okay, so in another view at the same query plan, okay? So the former one was more visual. This one is more for, plain text fans, so to speak. So, catalyst expression, just so you know, whenever you describe your query, you don't have just one single query, one single tree. You've got tree of trees. Okay, so you've got multi-tree tree, if I may put it this way, because you can have expressions which are pretty advanced, pretty expressive expressions. They are embedded in every operator that needed them. So imagine you've got tree of operators, and every operator has its own tree. So Spark SQL is about processing trees of trees. Now think about rules. Since rules are about processing trees, it's just a breeze to process trees of trees. If you know how to process trees, you can process trees of trees. Easy? Yeah, it should be like this. Okay, and every expression has this one single method called eval. No, it's not, sorry for my pronunciation. It's not evil. Is this how to pronounce it? We've got Halloween coming, so kind of like spooky way of explaining this eval. So eval will accept one single internal row. Internal row represents your data represented internally by Spark SQL. Okay, this is something that leaves outside JVM. Don't touch this unless you know what you're doing. Okay, because once you touch it in a wrong way, you will load entire data set onto your JVM, and you will, incur more frequent GCs, and you want to avoid it. Okay, so rules. Rules are pretty basic because they just have one single method, apply. And knowing that apply is special for Scala, you just say name of the rule, have this tree type. Tree type can be, it's tree node, so it can be, query plan or expression. That's pretty basic to write one rule, given there is only one method to write, to implement, and knowing that this, be careful, Jacek, you are too old for this. Okay, so, and given that you accept tree node and return tree type and return tree type, your very basic, very simple rule is just to accept, to return something you got, right? It's just that simple. Okay. And so this is just one of the many rules available in Spark SQL. You've got remove all hints, because there are only two hints, one hint supported by Spark SQL. It's a broadcast hint. The others are simply removed. So look at this. It just, hey, take this plan and transform it up, see all the unresolved hints, and if you hit unresolved hints, just take what's the children of this hint. And knowing that there is a tree, if you are not interested in one current node, you take the node that leaves behind this node. That's it. So you skip it. Okay? That's that simple. Okay, and the rule executor is the engine that executes all the queries. So look at this. It knows nothing about rules. It knows that every rule has this one little method called apply. And having this apply is all about executing a particular rule. So executing all rules in a batch will execute all rules, and you will get all the optimizations applied. Okay, so query execution. We've got 13 minutes. Oh, I need to be quick. But this is the gist of my presentation. Query execution is the gist of Spark SQL. Every query ends up as a data set. Every data set is in one-to-one relationship with something that's called query execution. So for math aficionados, if I may put it this way, you may say that every query is a query execution. And query execution is nothing else like another view on your query, or I should say, how to execute your query. There is a difference between how to execute your query and how your query looks like, correct? So you are responsible for expressing your needs to process your data, but you are not encouraged, you are not supposed to express your needs how to execute it. It's not your business, it's not your job. It's Spark's job to know how to execute this particular query. So there are two different angles looking at the same, a single structured query. One, how this query looks like. Another, how to execute this query. Okay? So this is query execution. Query execution ties these two words together. How your query looks like, also how to execute it. And it starts with, and you can look at this, query execution or access this query execution by saying dataset explain, or access this query execution that's in this one-to-one relationship with dataset by saying, hey, dataset, give me query execution. Okay? It's open developer API, you can use it. So yeah, it's free to explore it. And just to know, just to make a bridge connection between RDDs and SQL, today's Spark SQL or today's Spark, whenever you execute query execution to RDD, you will get this good old RDD. And you know what? It's 11 minutes before we finish this presentation. The only thing you need to understand is that Spark SQL is nothing more, nothing else but RDD processing generator. In other words, putting it in other words, Spark cannot execute anything that's not expressed using RDD data abstraction. You have to have your execution expressed using RDD API to execute anything using Spark, Apache Spark. Spark SQL makes your life much easier by saying, hey, you don't have to deal with this low-level RDD API, but just stick to your lovely Pandas, Python, or Java, Scala, SQL, and we'll take care of transforming this language into RDD API. So query execution knows how to do it. So you can look at Spark SQL as just another RDD-based application generator. That's it. Okay? That's the fundamental point behind Spark SQL. And that's the reason why we are now claiming you should stay away, not we, you should stay away from RDD API unless you know what you are losing and gaining by going so low level. It's as if you wanted to express your Java-based or Python-based applications using assembler. So I'm claiming that RDD API is now the assembler of Spark compared to what you can express using higher level language, be it SQL, Scala, Java, whatever in Spark SQL. Okay? Good. This is the thing you need to remember from this presentation. So this is another look at this query execution. Query execution is just a data abstraction in Spark SQL, but it's just pretty much this. So you start with SQL here, or dataset. So either you write your queries using SQL or dataset. It's up to you. I don't care. You may have also front ends from Pandas, from languages not officially supported by Spark, like F# or whatever, that would generate SQL or dataset, and Spark will take it and will build unresolved logical plan. This unresolved logical plan is just something Spark understands. So whenever you use something you understand, you are building tree out of these logical plans, or tree nodes. After that, analyzer kicks in and will optimize by means of logical rules, logical analyzer rules, will optimize this logical plan into something that's called analyzed logical plan. Analyzed logical plan, once you have it, once you have analyzed logical plan, it means that your query will give you an output. This output might not be correct from business perspective, but at least you pass the security gate, okay, or security checks. Once you have this analyzed logical plan, you will get an answer from Spark SQL execution engine. Then there is this stage where you say, hey, replace all the cached data with cached data that's cached, and well, replace all the nodes that are cached with cached data, and you have something that we call with cached data. It's one of the seven steps in this execution pipeline. Then logical optimizer kicks in that will translate cached data into very first optimized query plan. This query plan is the one and only optimized logical plan. After this optimized logical plan, planner will give you one single execution plan. This plan is not optimized. It's only when physical optimizer will take it and will create executed plan. And you know what? It happens for every query you execute. So part of the execution time of your structured queries is this. And you know what? At the very last step is to RDD. Hey, give me RDD that Spark knows how to execute. And this RDD describes your query that you expressed using higher level languages. And even better. This RDD is not just a copy of what you wrote. Well, it is, but in a sense, during this stage in physical optimization, there is code generation that will generate Java bytecode for you, so your code, your query is even faster. So to challenge you, I doubt you can write more performant query using RDD API than what you can get from Spark SQL out of the box, unless you are good at using RDD API in a proper way. So as you can see, I just said something that's generally true. If you are good with RDD API, yes, you can write this to RDD, manually, but you don't have time to study, RDD API and all the, intricacies of how to optimize your queries. And moreover, your data scientists and your data users would not appreciate your work even the fastest possible if you gave them this RDD API that has nothing to do with SQL, lovely pandas or data frames or whatever API you got used to. Correct? So it's all about the benefits of your users to somehow trade performance into a better, more expressive language. And this is what happens with Spark SQL. Okay? Spark SQL took care of translating higher level languages into this low level RDD API. And that's pretty much the gist of my talk. So we've got 4 minutes to go. And is this including Q&A? No. OK, so I've got 4 minutes. I'll go you through the slides. These slides are part of my training, in-depth training, how to use Spark SQL effectively. So I've got more to, to come to talk about. So I apologize if I don't go through all the slides. And by the way, they are available free of charge on my GitHub. So they are already available. So there is this Spark Analyzer. This Spark Analyzer will take your query plan and will analyze it and apply types. So after this query is analyzed, Spark knows what types to deal with and how to organize memory so this memory you gave Spark is used effectively or more effectively, okay? Then you've got, so rule analyzer is just another rule executor that just executes some rules to make your query better. There is this catalyst-based optimizer. Well, we used to say that Spark comes with catalyst optimizer, but catalyst optimizer from programming perspective is just an abstract class, so you cannot instantiate it. You need to instantiate proper class, so you need to have a subclass that comes with all the implementations that are needed. And so Catalyst Query Optimizer is just a base for 2 optimizers. One is Hive-specific, another is non-Hive optimizer. And they apply something that's called cost-based optimization, which is yet another rule. So Spark is rule-based execution engine, as well as cost-based optimizer or optimization-based. So you can just use 2 things that may seem orthogonal together, okay? Because this rule framework allows for much space for using different approaches to optimize your queries. So, and there is this also extended operator optimization rules endpoint that you can use, or hook that you can plug your own custom rules in and just see how you can optimize your queries even better. So Spark Logical Optimizer, another optimizer that's part of Spark SQL. When I say another optimizer, there are 2 optimizers. One is a logical optimizer, another is physical optimizer. So having two optimizers makes our query faster, or that's the purpose of these optimizers. And they've got extension points. So Spark Logical Optimizer has this pre-optimization batches, post-hoc optimization batches, and also there is this object called experimental methods that you can pass around and extend what's available in Logical Optimizer. And when you see in a moment that there is another third way to extend all these optimizers, all these query executions, you may be asking yourself, why do we need all these extension points? And the answer is simple. Well, it's an open source project. If you don't like something and you have a better way to deal with all these different optimizations, just create another unified layer and propose it as a pull request. Also, another point behind all this extensible framework is that it allows you for much experimentation. So if you like one extension point versus another, you can just use this rather than another one, okay? 13 seconds, okay, and so Spark Physical Optimizer. This is where all this whole stage code generation happens, reuse exchanges and subqueries, so you've got less exchanges, which are shuffles in RDD language, and you've got ensure requirements. This is where this bucketing is applied. So when you see that you've got buckets, pre-bucketed your data, you can reuse this information, or you can use this information, leverage it for better joins, okay? So rather than having shuffle hash joins, you can get much faster, much more effective joins. But, well, you need to apply some pre-organization to your data to get benefit from it. But no, it's just part of the very last step in this query execution. And that's pretty much it. I've got more to discuss, but since I've got run out of time, so this is the moment where you can have questions, and I'll bring answers, hopefully. So, do you have any questions?
And
right.
Hello. So we have a couple of questions on Slido. You can add more if you wish. So how does Spark's SQL query optimizer compare to the open source Greenplum's query optimizer for big data, a fork evolving from the foundations and lessons of established PostgreSQL?
Oh. It's a very good question. I cannot answer it directly because I've got no idea about this Greenplum's GP, blah, blah, blah. So I cannot comment on this specific part. I can only speak about Spark SQL. Spark SQL, as you may have remembered, came from Presto that originated from different databases. They wanted to build at Facebook, they wanted to build NoSQL database. So they built Presto, and they, borrowed all these nice ideas from different execution engines. They built this SQL parser. So Spark SQL tries to combine all the goodies from SQL engines, and so I know that PostgreSQL is one of them. So PostgreSQL had an impact, or still has an impact on Spark SQL, but speaking, specifically about this Greenplum, I cannot answer it in a proper words, okay?
We will find you at the party and ask all of those questions.
Yes.
Good. Do you have any advice on what to avoid with Spark SQL?
Well, what to avoid? Yes, there is one thing you should avoid at all costs. You should never ever, unless you know what you're doing, do typed operations in Spark SQL. So something that Spark, Scala, and Java developers could love, you should avoid at all costs. In other words, whenever you touch data set of your JVM object, think twice. You should go back to data frame. You should stick to data frame as much as possible. The less you touch JVM-specific object, the better, because there is no serialization and deserialization involved. Spark can optimize your queries in a much more performant way. So something like map, something like flat map. These are cool methods in Scala, in Java perhaps too, but you should avoid them, or at least explore if there is a better way to use with columns and apply untyped transformation to make and see if it gives you a much more performant execution.
Thank you. And maybe last question. So how much cost/money can you save by using Spark while storage and memory gets cheaper and cheaper?
Well, it depends on your investments already, but my clients are moving to Spark just because of this question. They hope and they get benefits, cost benefits from migrating to Spark. Well, there are other problems with Spark per se, because this is a different environment. There are some costs they need to spend, like having proper experience or proper experience. So people need to be taught and all this knowledge has to be acquired, but overall, it's pretty nice transition from pretty cost-ineffective solutions, relational solutions, into Spark, and you get much nicer environment. And I would have to, hear the proper current uses of your, or not proper, but current uses of your current architecture, just to say where to look for, benefits, cost benefits. If I had to answer this question, it's too broad to answer it in half a minute.
Sorry for that. So everybody who has still some questions, please find Jacek around. Thank you so much, Jacek. Please give him a warm hand of applause.
Thank you.